Good morning, Manchester. Okay, let's try that again. Good morning, Manchester! We're getting it. So thanks a lot for having me. Thanks a lot to the Open Credo guys for inviting me over. It's always a pleasure. And also thanks a lot, Daniel, for giving everything away. I have to rewrite my entire presentation, but you know, let's give it a try. My name is Michael Hausenblas. I'm a developer advocate. And I just figured that right in the middle here, there's a kind of divide. I'm trying to be here and here at the same time. I'm officially a developer and cloud advocate. I think I'm more of a distributed systems chester, really. But today, I'm really talking, or trying to talk a bit about, microservices and where we're heading. So when the Open Credo guys asked me for a title for this talk, I tried to come up with something a bit, cheeky, but hinting at also what is next, right? So essentially, the talk is structured in 3 parts. As you can imagine, the past, the now, the here and now, and the future. Who knows who these 2 gentlemen are? No one? Really? Wow. Yes. Come again? Dennis Ritchie and Ken Thompson. So these 2 gentlemen, they took a system called Multics and turned it into UNIX. And actually, they came up with one very important, or 2 very important things, and that is, what we know as the UNIX philosophy. The things they produce, they do one thing, and that well. So if we look at, all these little commands that we have there, they focus on one thing, right? And the main point being that you can actually compose them, right? So you take the output of one and, pipe them and build your applications around that. So you focus on one thing, doing that one thing well, and then you have a mechanism to wire up these little tools to create something bigger. And the title of that is The Origins of Microservices, and I blogged about that as well. And this is really, if you think about that, the basic underlying idea of microservices. You focus on one tiny thing, and then you find some way to compose these tiny things into something bigger, something useful for your user. So Martin Fowler, who's really good at spotting these trends and naming things, wrote about that in 2014 already, as Daniel also pointed out. And I tried to also come up with a definition or an explanation for that that's part of the blog post. Essentially, trying to make the point that microservices is just a fancy word for applying this UNIX philosophy to the web, to HTTP, JSON, and related technologies. And if you think about that, in the last couple of years, cloud native, containers, and so on, this is really the main point in terms of the technology. Now, let's move from the past to the present. This is a visualization of the AWS Microservices in 2008, I believe, that shows you a bit of the complexity. So there are a few microservices, as you can tell, and they are somewhat interconnected. And this is where typically people start out, the monolith. This is, by the way, a real monolith, so I'm talking about this one. And there's nothing wrong with that. So as much as, everyone is crazy about microservices and let's go all in and so on, you might want to step back and have a look at what you're currently at, what you're doing. And there are good reasons why we've been doing that for many years, right? There's nothing wrong with that. But there are also incentives and motivation to move to a more lightweight and loosely coupled organization. So there are a number of things, and I tried to capture that in this tooling versus culture, and Daniel already hinted at that. There are discussions, and I've been seeing that both at Mesosphere internally and at customers, very, very deeply rooted discussions around, should we be using gRPC over HTTP? Or are protocol buffers a better choice than JSON? And indeed, someone blogged about that as well. And last but not least, containers, containers, containers. Everyone doing containers right now. These are all valid discussions, no doubt about that. If you're into that, if you go down that route, you probably sooner or later get into these discussions, right? And it's a good thing to have. But on given an example here, a very simple demo of a microservices, nanoservices architecture. It's available on GitHub if you want to look it up. In certain cases, it probably doesn't make sense to put a microservice into a container. For example, I have a calendar proxy here that reads some data from a Google Calendar, and I've written that in Go, right? There is actually, in this context, not a big need to put that into a container. You can, but you don't have to. So I guess I'm trying to say with all these things, be it JSON versus protocol buffers, or gRPC versus HTTP, or containers or not, these are valid discussions and are good discussions, but maybe that is what you're really looking at. And I guess Daniel pointed it out once or twice, right? It's not so much about the tooling, that's all great, and increasingly open source and available, well-documented, thriving community, but it's really about thinking how to structure your organization to make that whole thing happening and successful, hopefully. So I wanted to go through a case study I'm somewhat familiar with. I was there on site last year, Otto being a kind of German Amazon, if you want, so an online retailer, and they said at some point in time they want to launch a new website. And this website, if you look at that, looks like a, what you would expect from a retailer. So you have search, and you have a catalog, and you have certain highlights there. You can obviously order stuff and so on. And they approached it in a very interesting way. They essentially hired a bunch of people that were not from their existing team, but they got them a room like this. And they said, right, you've got 6 months and a certain amount of euro, and you can choose whatever kind of technologies, you can do whatever you like, but you've got 6 months and you have to deliver in these 6 months. And some people would say, well, that's quite challenging, coming up with this. Don't forget, there is a lot of logistics. There are things like if someone orders, let's say, I don't know, a shirt, then you also have to make sure that this shirt is actually available and you ship it and so on. So there is a lot of integration with legacy, quote unquote, systems as well. But they decided to go for, yes, containerized, yes, Mesos-based, but the main point being a microservices architecture. And they actually blogged about that end of last year, and that's the reason why I can share that also in detail. And what I found interesting is that two things. The one thing, how they approached it, so they really built this microservices team structure first in there in terms of how they developed certain things like search or the catalog or the integration with the logistics system backend, or the mobile part so that it also looks nice and is usable on your mobile phone. But then also the question, how can you transfer that knowledge, how transfer the experience gained within that project to the wider organization? And that is, I guess, something, an ongoing journey. They still are in that. How can they actually transfer these lessons learned in a way that it's scalable, that can be applied to other parts of the organization? So I encourage you to read this blog post. It's really nicely explaining all the steps from the monolith to the microservices architecture. And you find many, many more examples out there if you Google for microservices success story or case study or whatever. They all seem to have something in common. They typically start out with a fresh team, with a not the existing IT infrastructure, but some new team that comes in. It's very focused time-wise and money-wise, and usually gets a lot of freedom. So people don't say, oh, we are a Java shop, or we are a .NET shop, or whatever, and that's the things you have to use. But management typically then would say, you've got so and so many months, or that and that amount of euro, and here is what we want you to do. So, since we already had such a success with the initial question, who is aware of the fallacies of distributed computing? Okay, at least one person, two, cool. So here I'm trying to make the point that microservices are really distributed systems, right? So you have a bunch of little services that are communicating typically over a local network, and since they are distributed systems, the fallacies of distributed computing apply. This might sound, a bit abstract. In fact, a practitioner, Peter Deutsch from Sun, back then when Sun still existed, wrote up these 8 fallacies. And one thing that is a kind of theme through that is the network. So consider that the network latency, network partitions, and whatnot are really a big central point to your architecture, to your implementation. And all the development and all the testing should be centered and focused around that issue. In the following, I tried to extract a few lessons learned from a number of projects I've seen and I've been involved with. And I'm more than happy to discuss that, either here on stage or later on, going through that step by step. Again, and that's why I said probably need to rewrite my slide, or if I would have known, I would have rewritten it. If you're going down that route, if you're planning to go all in regarding microservices, design team first. So think about who is going to participate, how you're going to structure that reporting line, and so on and so forth, and then choose your tooling. Then go into, should we use containers or this or that, right? Design team first. Another thing that you already mentioned, pointed out, polyglot programming, polyglot persistence, and so on and so forth. That's a great thing, right? Now I can benefit from the best in each category. I can say, I'm going to use some Ruby or Python here, I'm going to use some Java or Go or whatever here. But also think about the fact that if that one guy that you hired for that one microservice, due to whatever reasons, leaves, you have to hire someone else there. So if you are, again, let's say a Java shop or a .NET shop or whatever, you have a pretty homogeneous setup and you can probably hire people into the same culture. If you're going down the microservices route, you probably should be aware of that you will end up with a number of different languages in your microservices style architecture. So think about not only the today, but also about the tomorrow. How can you actually not only maintain, but also add further features on? Remember, I tried to make the point early on that microservices are distributed systems. And one thing that is really hard and also bit me in my arse more than once is debugging and tracing. So if you're trying to debug a monolith, it's hard, but believe me, debugging and tracing stuff in a microservices setup is even harder. So you really want to have the tooling there that helps you as a developer or DevOps to understand what is going on, where something is failing, and how these things interact and influence each other. Then there is the question of logging and log shipping. You have not now one application that spits out logs, but many applications or services that spit out logs at the same time. How do you get the overview of what is going on and can also drill down into a specific service and their log output? One of the things that quite often is an afterthought is monitoring, and especially if we're talking about containerized setups, then this instrumentation as a first-class citizen and directly at the beginning as a responsibility of a developer really is a must, I would argue. So if you're not instrumenting, if you're not providing deep insights, reporting about both the application level and the business level, metrics and what your application or service is actually doing at any point in time, you will have a very hard time later on to debug and trace things. So you really should think about monitoring as a first-class citizen. And last but not least, and Netflix made a great example with the Chaos Monkey, resilience testing in distributed systems or in microservices in our case is really at least strongly recommended. Not everyone might have the stomach for doing that, but I can tell you from my experience at least that it's really a good thing to do. So the basic idea here is that you proactively break things. You, for example, kill a certain container or take a whole node down, simulate a network partition or whatever you have to do in order to understand how is your system working and all the different parts working together. Especially if you think about this case study we had earlier on, let's say there is some Elasticsearch at the back end and there is something going wrong with the Elasticsearch cluster. The last thing you want to have is that the entire website is not usable anymore, right? What is okay, and that's the idea behind that, to figure out if things go wrong, how does your overall user-facing application react? You might say, we want to degrade gracefully. Let's say if Elasticsearch cluster is down, then it's okay that the search for the time being doesn't work or in whatever way is limited. But it's not okay if the entire website is not accessible anymore or people cannot order things just because the search part is not available. Okay. Here two shout-outs, two examples, and there are many, many more tools. Happy to supply you with a list if you want to. A very cool tool for especially containerized environments is Weavescope from our partner Weaveworks. Gives you a bit of an idea, process, container-wise and host-wise, what is going on, how are these different components communicating. You can drill down in each of them. You can even enter a container and see what's going on in there. You can filter and so on. So this is both from a developer perspective and ops perspective, or ideally DevOps, an awesome tool to see into your application, to see into your microservices style and figure out what is going on, either proactively or if you need to troubleshoot, get a deep insight. Another shout out to James Turnbull. He recently published a book, The Art of Monitoring, and again, trying to make that point, monitoring is not something, an afterthought that the ops guys were going to do later on once I've thrown the thing over the fence. But this is really something that you as a developer should consider in the first place, and if you're not familiar with monitoring, that is probably the best way to get into that. All right, so we talked about where microservices come from, where we are roughly, and I'm not claiming that I've covered each and every aspect, but aspects that are very, very important to me and what I've seen in the practice going wrong. So let's now have a quick look into the future. So I'm a huge fan of understanding compute as a kind of spectrum rather than black and white. So let's have a look at and start at the good old monolith. The unit of execution would be a machine. That would be your traditional three-tier architecture. Microservices, as I said, increasingly you will find containers, and containers are cool because that allows you, especially for certain languages, let's say Python, for example, or Ruby, where you have dependencies and you want to package that in a way that all your application level dependencies are guaranteed throughout from your laptop to production. So for example, if you take Docker with Marathon or Kubernetes or whatever, that would be a setup there. PaaS have been already around for a bit longer, and for a lack of better term, I'm using objects here, Heroku, Google App Engine, and so on and so forth. And that is what I'm going to talk in the next couple of slides, the new hot thing, the new cool kid in town, serverless. And I've seen there's a talk in the afternoon, so if you want to learn more about serverless, I suggest you look there. Here, the unit of execution really is a single function. So the groundbreaking and trailblazing example is AWS Lambda, but there are other templated serverless offerings around for a while, like IFTTT has been for many years. So one way to look at that is in terms of agility. From monolith to serverless, typically getting a new version out there increases to the right-hand side. The opposite picture we see in terms of maintenance. So if you're talking about a monolith, be it on a virtual machine or bare metal or whatever, versus serverless maintenance following roughly that. And don't be fooled, that doesn't mean that you don't have any ops at this part. It still requires some love and caretaking here, be it logging, monitoring, whatever. It's just that you don't have a machine that you can SSH in anymore, in a nutshell. And last but not least, also the costs per unit roughly follow that. So if you have to ramp up an entire machine versus serverless, where you essentially pay per successful function execution, that gives you a bit of an idea when to use what. So the concept as such is, as I said, the unit of compute is a single function. And the resources necessary to execute that function are somewhat dynamically allocated. Depends on the implementation where you look, but essentially that follows this. So you have a client, that could be curl or whatever, and you have some kind of infrastructure that provides this serverless interface. So you send in, typically have to register a function first in certain programming languages that are supported by the platform, and you send in certain parameters and you get back the result. And this Lambda functional programming that has a certain background there, and we come to that and the limitations in a moment as well. The main point, however, and just to make that clear, a serverless offering per se is close to useless, right? If you have something, and I did a POC based on DCOS, the open source project I'm looking after, took me a couple of hours. This is really simple, right? The actual implementation of the serverless offering. If you don't provide the integration with other things, like how do you actually trigger that? What kind of events trigger the function execution? Or routing, or access to storage, and so on and so forth, then you will have a bad day with only this backend here. So there are a couple of contenders out there. As mentioned, AWS Lambda being around the longest. Microsoft has Azure functions. There are Google Cloud functions. There are others like WebTask or Iron.io. And there are many, many more emerging. And as I said, there is a talk in the afternoon. You might want to go there and learn more about that. Just to clarify what the application areas might be. So typically you're talking about jobs. And in that sense, I see it somewhat, complementing the microservices long-running architecture. So you typically have short-running jobs that do something. They might increment something, might do some aggregation, whatever. Very often you find that with constrained devices in the IoT, mobile applications, stateless typically, and event-driven logic. So think of serverless as another tool in your toolbox. It's not a silver bullet and everyone does serverless from tomorrow on. And a word of caution, one area where people are sometimes having issues is with anything stateful. That's why I pointed out earlier on already the stateless, that typically while you sometimes want to keep some state around, serverless is really, really well suited for any kind of stateless applications. Okay, and I think that was already it. I'm happy to take questions right away or afterwards. And summarizing this talk, essentially, yes, do serverless and do microservices, but be aware of that tooling is maybe 10–20% of the challenge, and the major challenge around that is really an organizational one. And it's your colleague and your manager that's in the center of attention, and not necessarily containers or not. Okay, any questions? Do we have a mic or?
I don't think we have a mic.
Okay, then we
repeat the question. But any questions for myself or Michael, feel free to shout them out. We've got about 20 minutes before the next session, so it'd be nice to get to everyone grounded, make sure they understand what microservices are all about. Any questions you want to have to kind of kickstart the day, chuck them out now.
Can I just ask, was this being filmed? Can we watch it?
It's being filmed. I think we're only filming one track today. So there's 2 tracks. There's here and there's over just like around the way. So this is being filmed, yeah, as well. And also we'll make the slides available. So I'll ask all the presenters to give me the slides. We'll make the slides presentable in about hopefully within a week or so.
Yeah.
Gives us a little bit of time. Sorry, question.
Yeah, you mentioned containers in microservices. Can you give us some examples of containers? Or how you might use them?
So the question was examples of containers and where and when to use them? Right. So the basic challenge with containers is not so much that, it's hard to run them, right? You download Docker, you say Docker run, that's all cool. The big challenge around containers is really preparing the environment, so having a CI/CD pipeline that actually creates the container images, having some hygiene around the base images. So a rule of thumb is don't pull randomly from Docker Hub, but have a set of approved images in your organization. Let's say you have, I don't know, 3 or 4 different languages, Java and Python and whatnot. So you want to have some base images that are approved for your organization to be used internally, be it security or what footprint-wise or whatever. So if you have that in place, if you have a CI/CD pipeline that enables your folks to really produce the images in a proper way and automated way, then the main challenge is pretty much the same as with any microservice, to figure out how to combine these different containers. There are a few things around monitoring that are specific to containers because of the runtime, unlike virtual machines that typically run for weeks or whatever. Containers might only run for seconds or whatever. So this kind of monitoring where you say you put something in place and then you get the monitoring in place, that doesn't work. You need to actually, or typically you have that within the container or the container host already baked in. And then there are also a number of things that are specific to containers in terms of orchestration. So the naive approach would be to manually orchestrate them, which means to you SSH into a box and launch a Docker container manually, versus you're using container orchestration systems like Docker Swarm or Kubernetes or DCOS Marathon or whatever that automate that allow you to do upgrades, health checks, and so on and so forth. Anything you wanted to?
I'll hover by you, Mike. That's right. Yeah, thanks.
I'm going to share the mic.
Yeah.
If I ever get it.
You want me to? Excuse me 1 second, guys. I'll just move that line. Great question, actually. So often people, to some degrees, conflate containers and microservices, and they are distinct concepts. I think both Michael and I have talked about this quite a bit, in that you can do one without the other, but it's kind of like bread and jam. They go well together. That makes sense. So there's quite a bit of stuff out there. Shameless plug here, but check out the OpenCredo blog. And I also write for a website called infoq.com. And I did an article series about a month ago talking about containers and the hype curve. And exactly what you said, Michael, you summarized it perfectly. I had about 5 articles which was contributed from the community, talked about CI/CD being really important, even more so than, say, monoliths. So it's still super important in a monolith anyway. And we often recommend to get your kind of CI/CD pipeline, your continuous delivery pipeline in place, and also get sort of DevOps kind of concepts in place, DevOps being a broad label, and then kind of look at containers. But monitoring was a big challenge we found as well. Microservices bring their own challenge because you've suddenly got lots of individual things, but containers bring another layer of complexity in terms of they are Linux processes, and some monitoring tools aren't aware of those things, so we use Sysdig quite a lot. So Sysdig is a really cool tool. It's container, C-group aware, whereas some things aren't aware of C groups and namespaces in containers. So the series is called Containers Stepping Off the Hype Curve. So if you Google that, there should be some articles there that will sort of talk about what Michael's talked about as well. Right. Good question. Yeah, containers, very important. Anything else at all? You got that one.
When you were comparing monoliths and microservices, platform as a service and serverless, I was wondering why you had parsers separate from microservices.
Right, that's a fair observation or a fair question. It is sometimes hard to distinguish serverless and PaaS, to be honest, and there are discussions out there, where's the boundary? Some people argue... Right, right. So... Right, right. To be honest, and to be very frank with you here, this, spectrum that I showed here, you can certainly, view it the other way around, PaaS, serverless, or whatever. It should give you an idea of, or what I tried to align was the unit of execution, getting from something big, like a single machine, to something small. I don't really have a better explanation, what distinguishes serverless and PaaS, other than the focus. PaaS traditionally means a bit more heavyweight versus serverless means more lightweight, usually. But other than that, yeah.
Yeah, just to add on to what Mike was saying there, I think serverless, exactly what you're saying, Michael. What I would expect from a typical PaaS would be complete lifecycle support. So effectively, I do a git push, like Heroku, like Cloud Foundry, takes care of everything for me. I have a concept of service packs. So for example, in Cloud Foundry, I can pull a RabbitMQ instance, I can pull a MySQL database. Whereas things like Kubernetes and Mesos DCOS are amazing, but they're more containers as a service. We're calling it CAS. Now that's a bit of a slightly wrong name in some respects, because they're not really containers as a service, but they give you a less opinionated platform to deploy your things onto. So with a CAS, like Kubernetes or DCOS, you can choose how to deploy data stores. You might deploy them in your cloud using RDS or Azure data stores, that kind of thing, or you might choose to run a containerized version of MySQL. Though be very cautious of that, as you hinted, Michael. State and containers are still not quite there yet, I would say. But I would expect a lot more, sort of summarizing what I think Michael and I were saying, I would expect a lot more from a PaaS than I would a serverless infrastructure or a CAS, but I'd also be trading off flexibility, because for some enterprise development shops we work with, that's a great compromise. I've got 1,000 developers and I only want sort of certain ways to do things. Whereas some shops we work with, they want maximum flexibility, and then we use something like DCOS or Kubernetes.
And maybe following up on that, so PaaS would for me really be like this, the solution that you would be using for pretty much everything, whereas serverless I see as this, this is one tool in the toolbox that is, applicable for certain workloads, but not necessary for all of them. So maybe that's another line to divide that.
Yeah, or just adding on to that. But one thing I've said is one thing I've heard, sorry, with serverless, and Rafael's going to do a great talk actually later on today. I've already seen Rafael's talk. So if you're into serverless, go and see Rafael's talk. But one thing I've heard is they could be the new database trigger. Yeah, like if any of you use database triggers, they can be a nightmare to debug. Yeah, you have application logic in your front tier, say JavaScript, application logic in your middle tier, like Java, and you have application logic in your database, stored procedures, PLSQL triggers, that kind of thing. So be cautious. Serverless, really awesome. Totally on the innovation scale at the moment. We are playing with it in Open Credo, but it is very much in the innovator scale. Be aware of the trade-offs. It's sometimes hard. You can get emergent behavior, or you can struggle with debugging these things. And monitoring, as you said, Michael, is not quite there, is it?
And I guess that's why I put them under the future part.
Yeah.
All right, we have another question in the back here. Yes?
Yeah, my question is just about how would you approach debugging a serverless function, because it's obviously a problem because you don't have, well, it's easy if you're going to write a function that works straight out the box, but how do you go about debugging it and logging it?
Right, right. So the question was, how do you actually, from an development and operation point of view, deal with serverless? And the good answer is currently not much. So wherever you look, you will find, pretty much all of the containers are listed here. Maybe Raphael has some other insights in the afternoon, and I would also be very interested in learning more. The main problem is, still with containers, you have something you can look inside. You can SSH into or whatever. With serverless, you don't have that anymore. You're sending off your code and get back something and maybe have some side effect. So unless your platform, AWS Lambda or Azure Functions or whatever, supports that kind of inside introspection, you're pretty much out of luck. So this is something where I would say the biggest challenge, so if you get that right, maybe you have a chance to challenge Lambda here.
I think, great answer, Michael, to be honest. And what I just caveat is a lot of, so I sort of do an architecture role quite a bit, or an architect role, and a lot of what I do is about risk management, and obviously shared understanding as well within the team. But with the risk management point of view, I always weigh up with new technologies, what am I gaining? So serverless is amazing in terms of very reactive, very event-driven systems. Now my colleague Dom is going to be talking about event sourcing in the next room after this talk, which is well worth going along to, and CQRS, that kind of thing. But it's like, for me, it's often a trade-off with, say, Go and Java. Now, people are railing against Java, but it's a battle-hardened language. The tool chain is amazing, and I know I'm good to go with, say, Java EE or Spring Boot. I can whip something up very quickly. With Go, it's ridiculously powerful, really performant, but the tool chain isn't quite there yet, for example. It's good enough, don't get me wrong, but as in, like, Java's probably better. And it's kind of the same, like, with, like Michael said, like, with the cloud tooling, like, you look at AWS, Microsoft, and all the Google offerings, the tooling support is more advanced for the EC2-like instances, the compute instances, than it is the serverless. But it's a trade-off. Some things I really might need to leverage the power of serverless, so I'll take the risk of not being able to have the tool chain to develop and maybe not monitor it quite as well, but it's all about risk management. I go in and I go, I really need these things are the things I value. So I really need speed, I really need innovation speed, for example, and I'm willing to trade off visibility, that kind of thing.
Maybe if we have a look at one concrete example here. So that's what I guess I tried to say with this one. Imagine you have some kind of device, whatever it is. Let's say you have millions of those out there, and they send in 1 data point per hour. Would you rather ramp up a VM, a container, or invoke some serverless function? So I guess that is a pretty good use case for serverless, right? So you have many of these devices that invoke or send in data every now and then, and because it's just this 1 data point, it doesn't really make sense to spin up even a container, even if it just takes a second or whatever or less to spin up a container. A serverless function call would be probably preferable. Again, being able to look into that execution and see what is going wrong is really, really challenging. So the tools or the offerings that I've looked so far, they give you some insight. So you get a bit of logging, you get a bit of a few metrics out there, but really this kind of what you're. Let's take as an example the printf debugging, right? So where you can really see exactly where you are and or tracing is simply not there yet, or at least to my knowledge, what I've seen, it's lagging behind our standards, what we are used to or expecting from these environments. But there are really good use cases for that, and it's certainly something I encourage people to have a look at. Any other questions? Yes.
You talked a lot about the problems with the networking microservice architectures, and I was wondering if you'd seen any sort of version of a microservice architecture that was moving away from network protocols. So instead of using HTTP, using something that looks more like an in-memory call. So you've still got your deployable, scalable unit, but you're not relying so much on a heavy network.
No, because we're typically talking about, so in contrast to HPC and mainframe area, we are really talking about a network of commodity hardware. So little things that are communicating over the local network that you can scale out horizontally, and more in cloud environments. So you're talking about essentially 2 network challenges, right? Within, let's say, if you're deploying something on Azure and you have network links between your instances, but then also the network between your service or application and yourself as a user on a mobile phone or whatever. So these kind of shared memory or whatever setups that you used to have, I don't really see that. I don't know if you have any strong opinion about that.
I'll chuck in a couple of things. Hey, sir. I did. So I have seen people try to abstract away the networking. So Vertex is a good example there. Vertex does that kind of thing, interesting framework. Seneca.js does the same thing. They use event buses, effectively. So you don't, it's protocol agnostic, but you do have something routing messages and doing pattern matching. I've also seen someone called Peter Lowry, talk a lot about building, he builds highly performant Java services in the financial, in the fintech domain, where microseconds are talked about, not milliseconds. And he's got some really cool stuff. He did a very interesting talk at KubeCon New York. So if you Google Peter Lowry, KubeCon New York, he talked about some of these things about trying to abstract some of the networking away. But fundamentally, as I think Michael made the point really nicely in his talk, microservices at the moment are inherently distributed systems. I see Hausenblas have just put out a paper actually. So Hausenblas are a data grid. Very, very cool stuff. We use Hausenblas quite a bit actually. They do sort of in-memory data grids and distributed processing, that kind of thing. And Hausenblas have got a white paper that's just come out about microservices on Hausenblas, which is kind of using shared memory data grids to run microservices. So that might be worth checking out as well. I think at the moment it's sort of a niche area, I think, Michael, like that kind of thing. But a lot of the performance penalties and difficulties we're having with containers and microservices all center around networking, Sarah, as I think you were hinting at there. So I found, like, my journey to cloud and microservices over, say, 5–10 years, I've become a lot more networking savvy. I've had to. I've almost become like a network engineer sometimes, yeah. And I've become a lot more operating system savvy. Like, you know, I'm constantly on the terminal these days, like looking at things and playing around with it.
Just to be clear, the reason why I'm pushing back here a bit, or I'm cautious, is because of these, you know, the fallacy of distributed computing. Because at the end of the day, I mean, you might be able to put an abstraction on top of that, but it is very often a leaky abstraction. And it is, at the end of the day, if you need to debug things, if you need to figure out what is going on, you will find yourself on the network level. You will use, I don't know, netcat or ifconfig or whatever you're using to actually figure out what is going on, who is, you know, what port is talking to what port, or you know, a network partition or whatever. So at the end of the day, I would love to have something like that, but I don't really see that coming anytime soon. Maybe someone comes up with something like that, but yeah. Did we have another question?
One more question,
yeah.
I think.
Over here.
I'm just wondering, rather than the sort of new teams building new kit, in the sort of, for a lot of us, we have to deal with existing systems.
Oh, yes.
So paring that monolith down and adding this stuff on the side. What sort of mistakes or challenges do you see people typically experience in them trying to add microservices into an existing infrastructure?
That sounds like a question for Daniel.
So we like to say so the question is, when dealing with legacy or money-making systems, as we like to say, how do you actually deal with those things? And it's a really good point. So shameless plug, I'm doing a talk in a minute after this one that looks just at that, to be honest. It's called Microservices from 30,000-foot view. And I'm looking at the organizational architecture and operational aspects as well. But not to say, coming along to that, like Dom's doing an awesome talk about event sourcing as well. So for people that aren't coming along to my talk, the key challenges it's often around the people, if I'm honest, because people are sort of, we don't like change. We actively resist change sometimes. So when you've got a monolith, teams are typically organized around that monolith. We're optimized for deploying a monolith. So the biggest challenges are often breaking down teams to be sort of more cross-functional, to embrace more DevOps philosophies. They're often, like Martin Fowler said it better than I did. Martin Fowler said there is prerequisites for microservices, and they are pretty much DevOps in that it's rapid provisioning, a rapid deployment, and basic monitoring. So we need to educate teams and help teams kind of get those skills up sort of as well. And then it's all about, once you've got the kind of foundations in place of change the teams, got the supporting infrastructure, it's about defining service boundaries, interfaces, and contracts. Because you can do domain-driven design, you can do good architecture in a monolith, and I'll talk about that in a minute. Microservices, this is nothing new really. There's hard boundaries with a microservice. That's one thing that's nice. There is an HTTP layer, or there is something there that's kind of a shell around the edge of microservices. And that's amazing, because we can carve up our domain now. The flip side is it's really hard to get that right. So we do a lot of work training teams around context mapping, those kind of things from domain-driven design, understanding the relationship between domains, sharing a ubiquitous language, all these kind of things. So that's typically the third thing in this cycle is learning more about domain modeling, because it's more important now. With a monolith, you can often cheat. And And that's where the pain actually is. You cheat, and then you constantly have to that sort of pay down that technical debt. With microservices, if you get it right, you minimize some of the cheating, although you still can cheat as well. Even though like microservices are just an architectural style, good architectural principles like coupling and cohesion still very much apply. So we need to make sure the team's happy with those things. But does that sort of address some of the... Cool.
All right. I guess that's about it.
Pretty much, yeah. I think.
All right.
Yeah, next session I believe is at 10 past, so feel free to mill around for a minute.
All
I'll
right.
be talking about the 30,000-foot view of microservices. Dom will be talking about event sourcing and CQRS in the next room. So thanks to Michael once again.
Thank you.